The basic and most important function of an IGBT driver is to amplify the control signals. The IGBT is a component which rapidly charges and discharges the IGBT gate according to control signals. That's very basic. Let's see about that on a deeper level. An IGBT driver circuit is used to control the switching of an IGBT. The driver circuit provides the necessary gate current and gate to emitter voltage to turn on and off the IGBT. As you know, this IGBT is a voltage control device, which means the current flowing through the collector to emitter depends on the magnitude of voltage provided at the gate of the IGBT. And due to gate capacitance, certain bunch of circuits are required to charge and discharge the input capacitor, which switches the IGBT. A gate drive circuit of a high power IGBT is mainly made up of three sections. One is an isolation section, which electrically isolates the main control circuit and big power electronic system, just like this DDL just seen. Also in IGBT, the voltage at the collector and emitter changes periodically in the circuit, which might create common mode interference in the circuit. So to isolate high power from low power and minimize the common mode noise, the IGBT driver needs signal isolation. This circuit is made up of an either inductive or optocoupler based isolation. We have already seen these isolated gate drivers in one of our previous videos. You can click on this card if you would like to learn more about it. If a driver has transformer-based isolation barriers, then they are particularly robust with substantial voltage rating, which goes in range of 1 to 5 kV AC. Next is an interface circuit, which is basically made up of an operational amplifier which receives and amplifies signals that are coming from the isolation circuit. This circuit provides the appropriate output signal to the triggering circuit. And the final stage is switching transistors, which are usually made up of high side and low side switches, which charge and discharge the input capacitance of the IGBT. The high side switch provides the positive gate voltage to turn on, and low side switch provides the negative gate voltage which discharges the IGBT and eventually it turns off. Well, there are a variety of different techniques for turning the IGBT on and off. The most common is the resistance control voltage source. Here we apply a fixed turn on and turn off voltages at the gate, and the rate of current is controlled with an external resistor, which is also known as gate resistor. Well, we all know how important this gate resistance is. Need not to worry, if you don't know, I got your back. You can just watch this video by clicking here. When an IGBT needs to be switched on, usually the gate voltage needs to be around 15 volts. When it is switched off, the gate voltage needs to be in a same negative value with the same or less than the turning on gate voltage, for example, minus 10 volts. Well, we have already seen why an IGBT needs a negative gate voltage to turn it off in this video. So to provide different voltage at each level, we need an extra DC to DC converter which would provide the positive and negative voltage having the same reference point as that of high power circuit. And it should be isolated from the control signal. The gate driver IC can operate at a low voltage level, but this DC to DC converter is needed to increase the voltage to the requirement for the IGBT. Let's take an example. There is a power electronic circuit and we need to drive this IGBT. Now, according to feedback, the control signal will provide the PWM to the driver circuit. This control signal usually comes from a microcontroller, which gives output in the range of 0 to 3.3 volts or 0 to 5 volts. And this is not sufficient for an IGBT. So this control signal goes to the isolation part of the driver circuit. Here, If this isolation circuit is the part of driver IC itself, which is usually the case in the modern designs, then it needs a power supply. Let's call it PS1. The isolation circuit will provide the same PWM which will be galvanically isolated. The signal goes to the amplifier, which amplifies the small pulses and provides the switching signal to these internal switches. These high side and low side switches provide the signal into 15 volts and minus 10 volts for the gate of the IGBT. For this part again, we require a different power supply, that is a DC to DC converter, which we just talked about, and we'll call it PS2. And that's how a basic IGBT gate driver is made. But we can't directly use this solution. We are dealing with very high power here. So safety is the biggest concern. Well, we need to add some safety circuitry like short circuit protection, under voltage protection, overcurrent protection, and transient protection at the gate. This protection circuit is very crucial at the driver circuit because in the end, it is the bridge between high power and control circuit in the system. If anything goes wrong, the repercussions will be very dangerous. So many driver ICs come with inbuilt short circuit detection or overvoltage detection blocks, which detect these faults, raise a red flag, and shuts down the IGBT right away. To minimize the transient at the gate, we can use transient suppression diodes. Apart from that, we need to take care of the tail current, secondary turn on, and gate ringing during the IGBT driving. But that part is for another video. Well, that is what a basic IGBT driver is made up of. I've added all the references on this topic in the description. If you like my videos, then hit the like button and please subscribe to my channel. It helps the YouTube algorithm to promote my videos to more electronic enthusiasts like you. If you have any questions, you can write them down in the comment section or email me. And finally, thank you so much for watching this video.